Hi and welcome to John's Maths Book. In this video, we'll be exploring another key concept in mathematics. If you find this tutorial helpful, then please show your support by subscribing, liking, and leaving a comment. Your positive engagement helps me create more content and allows me to bring you more valuable maths lessons. Without further ado, let's go over to the whiteboard. Let's look at a method for solving first-order linear differential equations that uses something called an integrating factor. A linear differential equation is of the form shown here, where dy by dx is equal to p of x multiplied by y, and this equals q of x. Note that the functions p of x and q of x can be constants. For a more complete explanation on how to identify first-order linear differential equations, please see this video. Now, to see how this method works, let's multiply the left-hand side and the right-hand side by a function f of x. If we look carefully at the left-hand side of the equation, we see that it's similar to a result we would obtain if we took the derivative for f of x multiplied by y using the product rule. So let's demonstrate this. So the derivative of f of x multiplied by y is f of x multiplied by the derivative of y, so dy by dx, plus the derivative of f of x multiplied by y. If we now examine both equations, we see that f of x multiplied by dy dx is the same in both equations. And the difference is we have f of x multiplied by p of x in the first equation and f prime of x in the second equation. And so for this equation to be equal to this equation, f prime of x must be equal to f of x multiplied by p of x. And so if we could solve the equation where f prime of x is equal to f of x multiplied by p of x and find a solution for f of x, we would then have the derivative of f of x y equal to f of x q of x, taken from this equation here. We'd then be able to solve this by integrating both sides of the equation to give f of x y is equal to the integral of f of x q of x dx plus a constant of integration c. And this will be the general solution to the differential equation. And in this case, the function f of x is known as the integrating factor. So now let's try and solve the equation f prime of x equals f of x p of x to find f of x, the integrating factor. So dividing both sides of the equation by f of x, we have f prime of x divided by f of x is equal to p of x. And then we can integrate both sides of the equation with respect to x. So we have the integral of f prime of x over f of x dx is equal to the integral of px dx. And the integral of f prime of x divided by f of x dx evaluates to the natural log of the absolute value of the function of x, which is equal to the integral of p of x dx. And then if we exponentiate both sides of the equation, we find that f of x is equal to e to the power of the integral of p of x dx, which becomes our integrating factor. So we can replace f of x in the general solution to the differential equation shown here. And the general solution then becomes e to the power of the integral of px dx multiplied by y is equal to the integral of e to the power of the integral of px dx multiplied by qx dx plus a constant of integration c.